When your computer's not working correctly, has anyone ever told you to clear your cache? Well, in this video, we're going to be talking about what a cache is, what caching is, why it's useful, and in the end, we'll be actually implementing cache and caching in Python. So let's get started. The definition of caching is just to store frequently demanded things closer to those asking for it. Now, this seems like a very, very simple definition that we can use in our daily lives. For example, let's say that my teacher has assigned me a book report. All right, so or not a book report. Let's say a series report. Okay, a series report on the Harry Potter series. So it's just like a book report, except you have to write about the whole series. Okay, I don't know if this is an actual thing. I'm just making it up. So you're here with your computer and everything, trying to write the book report, but you've actually never read the books, and you don't have the books. So you need to go to the library and get the books. All right. So, okay, that's not that hard of a task. I can just go to this library. We'll say that this is the library. Okay. It's not the best drawing, but we'll just say that this is the library. Okay. And this library, it has the books. So we have our books. And actually we'll just put it in a whole package. So this whole thing's our books. So you can see we have our library. It's not the best one, but it's good enough. To make this a bit better, right? But there's a library, and we need to get the series. Okay, so okay, pretty simple. We just go to the library, and we'll say that the library is 5 miles away. And it's pretty reasonable if you have like a big like town. And yeah, so we just go to the library and we read the first book. Okay, so let's say that we have 2 weeks to finish this book report, and but the goal is to finish, or we'll say that you have 1 week to finish the book report. So I believe that there's 7 books in Harry Potter. There's 7 books in Harry Potter, and 7 days, so that fits perfectly. So every day I read a book, and I mean, that's probably the best that I can do. I don't think I can read more than a book of Harry Potter every single day. So that's a pretty good, or that's a pretty a reasonable goal to achieve, if you're a vivacious reader. So you take the book, you read the books in the library, and you just come back home. Okay, so let's say every day what you want to do is you just go to the library, you read a book, and you just come back home. And then you type your some of your book report. And this is 5 miles there, 5 miles back. And this, if you're going maybe 25 miles an hour, this can take about, we'll say, somewhere between 15 and 20 minutes. Okay. So every day is 20 minutes, which counts to 140 minutes for the whole week. Okay. Now this 140 minutes is a lot, right? It is 2 1/3 hours, or 2 hours and 20 minutes, and this time could be used for other things like reading, rather than driving. So, or walking, or however you're doing. This is just an example if you're driving, but if walking could take much longer. But so there has to be a better way. I have to be able to save this time, and obviously, there is. Okay, so what we can just do is we can just take the books with us. We can just check out the books. So I have this, and I'm just checking it out, and this will only take 20 minutes in total. Just there and back. So we save around 2 hours of time. That's great. So we're just going to put this whole series on our desk. So now we don't have to drive for 20 minutes every single day to get, we don't need to waste 20 minutes every day to drive. Well, it's not wasting time, but we can save that time. and we can just bring it to our house. And that is probably what you would do. But like both cases are possible, and that's just a very, very simple example of caching in daily life. Just with this definition. So let's just clear up this definition for the example. So it says to store frequently demanded things closer to those asking for it. And we'll just be pushing this a bit closer. So basically we're storing frequently demanded things. Okay, so actually just don't worry about this first. We'll just talk about frequently demanded things. So we need, first for this to work, we need something that's frequently demanded. So this series is frequently demanded because we don't read the book in one day. Like, we're not just taking one trip to the library, finishing the whole series and coming back. Then there's really no point to take the whole series and put it on your desk because you're done with the series, right? So it's frequently demanded because we frequently need it. 7 times we need it. Without checking it out, we would have to go there 7 times. And they're demanded because we need them, right? We can't really write a series report on Harry Potter if we haven't read the books. So that's why they are demanded, and we need them, and we need them frequently. And all we're doing is we're just taking what we need frequently, and we're just putting it closer to us so we can save this time. And in this case, it comes in the time to drive. But in the different examples, it varies. It's just the time that it takes to get some information from somewhere and bring it back. So you can save that time just by bringing it closer to you. So that is caching for you. That is a pretty simple example for caching. So I'll just separate this. But now, what happens when your whole desk is full? Because the library, it has lots of storage. It has shelves and shelves of books, and it can store thousands of books. Your desk can maybe store 7 books, the series, and your desk is full. So for the next book report, what do you do? Well, you have the series, and let's say you have another book report for another book report for another class. Okay. Or this might just be for a blog. Okay, so yeah, this is your class, and now you want to write a blog. So right now you only have so much room on your desk, and it's full. Okay, so you're like, so now what do I have to do? So I'm caching. I can't cache anymore because I don't have any more space on my desk. So I have to clear space to get my new books, right? So there are 2 main or 2 easy to implement ways to do this. The first is our LRU, which stands for least recently used, and we'll be using this in our program when we're implementing it through Python. So this stands for least recently used, as I kind of just said. Okay, so this is the least used, we'll just say. Okay. For example, let's say that these books are the Harry Potter books. So this is the first one. This is the second one. This is the third one. This is the fourth one. This is the 5th one. This is the 6th one. And this is the 7th. Okay. So your first one, we'll say the last time you read it was like a day ago or 6 days ago. This is like 5 days ago. And then so on. So 4 days, 3 days, 2 days, and then 1 day, and then 1 hour. Okay. So now what it's just going to do is it's just going to see which one is least recently used. So which means which one did I use the least, or I'm not using frequently now. And we'll see that this is the one, the first book, because this is 6 days ago. So it obviously we can see here that in real life or in the real world, when we're checking out these books. If we're done with the book, then we don't really need anymore. So obviously we will just return the books that we don't need. But for a computer, an easy algorithm to do is just to see which one's the least recently used. So when it doesn't know if you finished the book or if you are still reading it, it's just like, okay, well, just logically, if you haven't read it if you read it, or the book that's read, that hasn't been, or sorry, the book that is least recently used or hasn't been used recently is probably the one that is not the least important, at least now. So that's why it should take out this, and you can do this for a number of these. So yep, so that's that. That is the first method or algorithm, and this is mostly these are just I'm just showing you these because we will be using these methods when we're implementing it in Python. So the next one is R, which I believe stands for random replacement. So this is just going to take out a random book, and I mean, it seems kind of weird and crazy that it's just taking out a random book. And I mean, it kind of is, but in simpler applications, where the data isn't really, when it's not like the series or like a book series where you actually need all the data, it just removes a random one if the data isn't that important, and it can just replace it with another one that's just as important. But I don't really use this often. We're not going to use this in our implementation, but I just wanted to cover it. So it's just going to take out a random book. It's pretty simple, but yeah. So that's that. So we have LRU and RR. So least recently used and random replacement. So yeah, that is what caching is and why it's useful. All right. So we're going to be doing is we're actually going to be implementing caching with this simple Fibonacci sequence function. So for those of you who do not know what the Fibonacci sequence is, it's essentially saying x plus x minus 1 sum. So for example, 0 plus 1 is 1, 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 2 is 5, 5 plus 3 is 8, 13 plus 8 is 21, and 21 plus 13, wait, I didn't add that one, but 21 plus 13 would be 34. So, and the sequence keeps going on, so whichever number you're on, plus the number before it, will get you the next number in the Fibonacci sequence. So what this is saying is if I want the Fibonacci number of 2, or we'll say 20, is the Fibonacci number of 19 plus the Fibonacci number of 18. And the Fibonacci number of 19 is the Fibonacci number of 18 plus 17. And the Fibonacci number of 18 is the Fibonacci number of 17 plus 16. And the Fibonacci number of 17 is the Fibonacci number of 16 plus 15. So it just keeps repeating that same idea or this same line of code over and over and over again till we get the Fibonacci number of 1 plus the Fibonacci number of 2. Or Fibonacci number of 2 plus the Fibonacci number of 1. So so the bigger that you get in the numbers, the more iterations each number has as you keep going. So let me show you what I mean by that. So if I want to get the Fibonacci number of 30, I just run this and I get 8,200 or not 8,200, sorry, 832,140. Okay, and actually let's try to get the time that it took to get this. So let's import time. And we can say that the starting time is the time, and the ending time is also the time. Now what we want to do is we just want to print the time out. Right? So we can do this pretty simply. And this should just tell us how long it took for this Fibonacci or for this command to be run, and this is half a second, if I'm correct. So this took half a second to do this. It ran fairly quickly, not even a second, and that's great. So let's just keep this number in mind. We'll just say half a second. And now what if we did 35? Well, as you can see, it's not just 5 more iterations. It is it's many more iterations, because it's power. It's not just adding iterations to it. So you can see this is 4.7 seconds. So that's actually a massive difference. Well, not massive, but it's a pretty big difference. It's 4.2 seconds. But now what if we do 35 and 40? So if you remember, 35 was 4.7 seconds. So now let's see what 40 is. So now you may think that it should be around 4 seconds different. But as you'll see, it is not, because as I just said, it's the bigger you go, the worth for each number is many more iterations. So this could be like a lot. This could be the bigger you go, the numbers can be like thousands more iterations, or not thousands, we'll say hundreds more iterations. So this just the difference of 5 could take up to a minute and 30 seconds. I would say the realistic difference, that maximum would be anything between 40 seconds and 2 minutes would probably be the time that the difference between 35 and 40. And you'll see it takes very long. But finally we get it. So this is 51 seconds, and this is actually one of the lowest times that I've gotten. The last one that I did, I got a 98 seconds, and the one before that I got 120 seconds, I think. Yeah. So so this is not only 4 seconds. This is like 45 seconds. So that's a pretty big difference. And as you'll see, as we keep going, for 50, this could take like 5 minutes realistically, and mathematically speaking, because now if the difference between 35 and 40 is like this big, it's anywhere from 40 seconds to 2 minutes. The difference between 40 and 50 could be anywhere from it could be anywhere from like a 5-minute difference, or like a 3-minute difference, to like a 10-minute difference. They're not actually exactly sure, because I never tried it for 50, but anywhere past that would just take too long, and you would just not want to wait. But maybe we can wait this out and see how long this takes, just to see the massive number that it would be. But while we're waiting for that, let us talk about how we can use caching to slow or speed up the process massively. So basically, caching allows us to get frequent data, and we can put it in our cache, right? So basically, we can get the Fibonacci number for 49, and we can store that in our cache, and 48 and 47, so we don't have to keep doing the same thing over and over again, where we can have these stored values, so we don't have to calculate the whole thing. Because if we want to get the Fibonacci number of 50, we need to get the Fibonacci number of everything before it, and that can take a long time. So we can just have these values that we store. Like maybe we can get the 10 values of the Fibonacci sequence. Like we can get from 40 or 50 to 40, and then we can or we can get to 50 to like 10, and then we can easily just finish the rest of the output. So you can see it's still not done. Actually, I don't think we have time to wait for the whole thing. Maybe when the video's over, it's gonna be done. But so let's actually start implementing the cache. So you can kind of see how we can store these values in there, so we don't have to keep doing the same thing over and over again, where we can just give the values, and we can just go on to the next Fibonacci number. So yeah, so that's that. So move on, which I was expecting. Not going to say I wasn't. So yeah, so let's get started. So it's going to be very simple to actually implement cache just using a module. This module, I believe, is called func tools or function tools. I believe so. So we'll try that. I want to import cache. Okay, so let's just run this and see if this works. I'm not sure. Okay, actually, what did we just do? We ruined the 50 Fibonacci number. But we didn't really, because now we just have to wait more time. So basically, you just import this, and we just use the cache decorator. And this will work perfectly, and this will actually allow us to use cache. So as you may see, that my predictions are true, and this will not be showing up for many minutes. So I'm not going to wait, but now we actually just implemented cache. So with 2 lines of code, we actually implemented cache, and this stores like as many values as we want. So when we run this, we predicted anywhere from 5 to 20 minutes or above. Now let's see that we can run it in less than a second. Bam. So with our cache, we ran it in less than 0.008 seconds. And that's like 100 times faster than when we did the Fibonacci sequence for like 20. So like think about that. Now let's go even bigger. Let's try to do the 100, which could take an hour or so, right? We got it in like 0.01 milliseconds. And the maximum that would be this recur is 400, and this is still 0.01 milliseconds, and this could take many hours to do that. Again, mathematically speaking. So yeah, you can just see that we've actually implemented caching right now. And the last thing I just want to talk about is using the LRU, the least recently used way of deleting, because in this case we have a lot of space, and we can use the LRU to limit the amount of items that can be stored in our cache. So we can just change this to LRU cache if I am right, and we can change this decorator to LRU cache. Okay. So now when we run this, we still get the same output, and now we can right now this is just this is the same thing as regular cache, but we can actually have a max size of like 10, and this will allow us to change the items in our so the smaller it is, the slower it takes. So if I'm at like 3, this will take longer than I expect. Like this is it's the same exact thing. We'll do 2, see how that turns out. And now you can see it's actually waiting some time, because 2 is pretty much useless, and it should. It's a bit faster, but it's not that much faster. And 1 is definitely useless. It's not going to help you with anything. So the bigger, you'll see it goes faster. With 1,000, it's still that split millisecond, or even less, 0.01 milliseconds. So you can play around with this, see how you like it, but that is caching for you. So we just created our first cache through Python with our Fibonacci series or sequence. And yeah, so that's pretty neat if you ask me. Alright guys, so that's it for this video. I hope you guys enjoyed. If you guys did, please hit that like button down below. And I will be creating a lot of new videos on surrounding this topic and other cool topics relating to caching. So if you guys are interested in getting recommendations for the new videos to watch, please hit that red subscribe button down below as well. My recommendations for the next videos for you guys to watch is like regarding SQL and SQL with caching. So I will be creating a video on how to use caching with your queries in SQL or SQL. And also, if you want to go more into Python, I do have a couple courses on those. I would recommend, if you haven't already, to learn GUI or graphical user interface. I created a course about a month ago on Tkinter that I'll put down below. I also recommend, if you guys are interested in going further into Python, to learn about neural networks. I have a TensorFlow course that you guys can check out down below. I'll put the link to it down below. And just get started with your neural network journey. Yeah, so those are my recommendations. Once again, thank you guys for watching this video. I hope you guys enjoyed. Peace.